Okay, problem number 2, part D. So this problem is different than almost anything we've seen so far because we have an object that's going to end up moving in two different directions. What we have is a velocity arrow pointing straight up, showing us the direction of the motion of the ball, but our acceleration arrow is pointed to the right. So for our description, we need to talk about the direction of each of those arrows and then what's going to happen to the ball. So let's do that first. For the description, tell me about the velocity. So the velocity of this ball is pointed upward. That is our positive direction, so I'm going to put a plus sign, but I also want to put that it's going up. Now the acceleration, it's moving to the right, which is our positive direction, so I am going to put a plus sign, but I'm also going to put that this is moving to the right. Because even though they're both positive, they're not really in the same direction. Okay, now we have to talk about what actually happens to this ball. So we know that if velocity and acceleration are in the same direction, the object is going to speed up. But our velocity is pointed upward, our acceleration is pointed to the right. So here's what's going to happen. The ball will move upward, obviously, that's the direction of our velocity. This acceleration is trying to push it. However, it's not trying to push it up or down, it's simply just pushing to the right. So that acceleration does not affect the upward motion of the ball at all. So moving upward, this ball is going to stay a constant velocity. So let's go ahead and say that. Put this in blue, how about? Okay, so moving upward, we have a constant velocity. However, that acceleration is going to still push to the right. So it will accelerate because of that acceleration, but that's only accelerating to the right. So it will speed up to the right. So kind of two different motions here. Constant velocity upward, speeding up to the right. Now that gets extremely confusing for your motion diagram because we have two different directions we have to show. Well, if we have two different directions to show, we need to show two different axes to do that. So we have our vertical axis, what it's doing as it goes up. We also have that horizontal axis as it moves to the right. So we're still going to label our 0 here in the corner. We're going to label our vertical axis y as it moves up and our horizontal axis x. Alright, so it's starting at a position of 0. Put a dot right here at the origin, and it's moving up. As it moves up, it's moving in equal increments. So you don't necessarily have to write this, but I just want to put it on here to make sure you see it. As it goes up, these distances are kind of staying constant. And I know that's not perfect, but it gives you an idea. However, as it's moving to the right, it's going to speed up. So it might move to the right only a little bit at first, but then these are going to kind of spread out. Get further and further apart. So what happens is, if I get my marker back here, as it goes up in an increment and a little bit to the right. Next time it goes up the same amount, but a little more to the right. Next time it goes up the same amount, but a little more to the right. up the same amount, but even more to the right. So you end up with this motion diagram that looks a little funky. Kind of looks like your accelerated curves that you've seen in some of your graphs. If you connect the dots, they're kind of angled like this. Okay, the arrows are getting longer, so you can see it is accelerating. Now, the arrow to the side showing the direction of that acceleration, those should only be to the right, because our acceleration was only pointed in that direction. So next to each of those dots, you should have a little arrow pointing only to the right, showing that direction of the acceleration. It's a weird one, but that is 2 part D.